just briefly review again. So this is downsampling. This downsampling. And downsampling is this part. This downsampling, or called encoder, also called backbone or encoder. So this one. But for more details, you need to recover back to the original resolution. So in this part, you need to have an upsampling. But so far, because upsampling, from after downsampling, after encode, it will lose the information. So far, people still think about, for the upsampling, how can we recover the losing information? So people still think about different methods to solve this upsampling problems here. So the same. So here is downsampling. Again, this is a VGG16. So you'll see one downsampling, second, third, fourth, and fifth. So usually after AlexNet, we have a 5 downsampling. AlexNet has only two or three downsampling, but VGG, from VGG, people start to use 5 downsampling. For between each downsampling, they have a different kind of convolution to extract the information. Okay, this is upsampling, also called deconvolution. Okay, a different kind of name to call this one. So we'll do upsampling, downsampling 5 times, upsampling 5 times to recover the original information. But between here, some people use the fully connection. Some people use fully convolution. Okay, fully connection is the connection will fix. That's meaning your input size will be fixed. Fully convolution is the convolution is filter, 3 by 3, 5 by 5 filters. So the input size can be different. It's not fixed because it's the convolution. So because we are from here downsampling, upsampling, we will lose the information, right? The small size. Originally 224 by 224. Right now becomes 7 by 7. So you will lose a lot of information. So people try to recover those information based on the shortcut from original. This original resolution information they provide here in the diffusion. Shortcut is very important. What I say is that because in this one you lose the information. So no matter how you do the upsampling, your information still lose. So what can you do is that many people start to use shortcut, try to extract the information from the original resolution and copy to here. Okay, so that's very important. So right now, all the downsampling, upsampling, they all use shortcut method. Here, the important one is that Retina. I keep tell you, RetinaNet is very important. So I worry when my lab will cooperate with the Intel. But if Intel, they don't support the RetinaNet, that's a big problem to us. I worry about this one. Okay, because RetinaNet is very important. There are many methods to solve the problems. So RetinaNet is a good one. And RetinaNet, see, there's a RetinaNet. They have a downsampling, there's backbone. They have an upsampling. They call feature perimeter network, FPN. They have a shortcut here. This shortcut. This one is the same as this one. but they represent by different representation。他们呈现用不同方式，你不要以为这两个不一样，没有，这两个一样。这是 down sampling、up sampling， 这是 down sampling， 这是 up sampling。They have a shortcut here. So after they do up sampling, and here they do classification. They do the bounding box here. So this is called head. So retina, why retina is important? Because they have a good result, and they have many methods in retina. So far, people still use it or improve. So retina is a good fundamental network. People improve based on retina net, and also they have a backbone. They do the neck, they do the head. 它慢慢有成型了，所以你会发现后面的深度学习慢慢就是有 backbone、有 neck、有 head。那 neck 就是 upsampling 这一块。那最后是最终是用 head， 就是你要看要去感知那个结果就 head。那这里有 classification、bounding box。Okay, so retina net is very important. And here for the bounding box detection, there were two approach. One, this is we call RPN, region proposal network. Region, what's the region? It's bounding box called region. Bounding box. Proposal, what's the proposal? Proposal is meaning prediction. Proposal. So it's prediction network. So it's a bounding box prediction network. Okay, this one bounding box. But this one is a feature perimeter network. Don't confuse. It's totally different. But sometimes I think the student will confuse. So this feature perimeter is 那个叫什么？金字塔型嘛，金字塔，所以这是像金字塔。所以 pyramid network 是金字塔的 network。你要把它想成 pyramid 就是金字塔，所以 this called FPN. This called region RPN. And RPN has two methods. One method is called one stage. It's mean RPN is important because they have an anchor, ANCHOR. They have an anchor. To try to define some anchor. Okay, we'll talk about anchor later. 他会跟你先确定一下有不同大小的那个 bounding box 大小，然后再去。那 bounding box 他先帮你画好，那你再从 bounding box 里面去看里面有物体这样子。So this anchor. So this one has the anchor. There's two stage. Two stage is they have a RPN here. One stage has no RPN, but they have an anchor. Two stage they have a RPN. RPN also has an anchor. So this has anchor here. This anchor here. Okay. So they do the detection, and then finally they based on the detection result, and they do classification. So there's two stage. So which one is better? Before, this is better because they separate the region detection on RPN. 以前这是比较好，因为它就是 RPN 就专门在做那个 bounding box 的 detection， 就独立出来做这个 network， 只要独立一个 network 变成一个 module， so RPN is kind of we call module， 独立一个模组。This module focus on region proposal, region detection. So RPN has different methods, not only one RPN. They have different kind of RPN. So they improve the detection result. And based on the detection, this output is a detection box. And based on detection box, this one is a feature. This is a feature. This is only detection box. So based on the detection box, they try to extract the feature and try to do the more analysis here. So before, the two stage has a better result. And one stage here is It's not only detection, also recognition. So this is more complicated, but it's fast. So we say one stage is fast, but accuracy is low. So YOLO 1, 2, the accuracy is not good, but it's fast because it is one stage. Some other people, not YOLO, some other people, but YOLO tell you, okay, my accuracy is not so good. It's good, but not good enough, I should say. It's good enough, but not good enough. But I'm faster. So YOLO is good if because it's faster. But two stage, they have a slow speed because they have an individual RPM, but the accuracy is higher. Okay, so that's faster RCNN. But right now, this is become the improve this one. So this become they have a higher accuracy. So which one is better right now? It depends on the network. So like a YOLO V4, right now they have a good result based on this one. Okay, but however, RPN this one they become faster. So both methods right now is not easy to judge which one is better. Okay, but to me, I will prefer use this one because if I have a problems, I find the problems, it's easy for me to understand the problem probably is from here or from the other one. 就我现在如果叫我选择，我还是会用 two stage。为什么？因为现在都模组化了。那模组化你出现问题的时候，你比较容易知道是哪个模组出问题，你才可以改善它。你这个全部绑在一起。One stage is to mix anything together. So when you have problems, you don't know where is the problem. When you have problem, you don't know where is problems. You don't know which, because there's only one straight network, but you don't know what happened in the individual one. Okay, so this is easy to debug. So because we have this kind of concept, so YOLO, I mean from retina, we have a backbone, neck, head. Okay, and this anchor is here, bounding box here because we have a box. So anchor is here. So after retina, YOLO V4 has good contribution because they have a more like a modularized. YOLO V4 它有很大贡献是都把它模组化的很漂亮，贡献蛮好，所以YOLO V4 最主要是 see this backbone, right? And they try to this paper organize the backbone has those backbones, 就有这么多 backbones， 它把模组化。那 neck 这边，neck 有这么多种 neck 这样子。那本身 YOLO V4 is based on the PNet， 它用 PNet 来做，所以 YOLO V4 本身里面很多东西不是它的，但是它把它整合起来、融合起来，变成一个很好的就 integration， 所以 this very good contribution。它做这个整合工程，加速的动作这样子。好，那继续上去。But here they have a SPP， 这我们有时间再讲啊。这有个 SPP 加进来，所以 this backbone neck。Okay, so they can directly from neck, you can come to here. So this become one head. So this is one stage. YOLO V4, you can based on the neck feature pyramid network. You can put here. So this one become one stage. Okay. You can also do the other way. It's two stage. This meaning you come here to be RPN. After RPN, you have a region. Based on the region, only the region, you connect to here. Okay, because I say again, because YOLO V4 they will demodularize， 它已经模组化了。So you can 模组化意思是说什么叫模组化？就是你可以做组合啦，比较容易做组合的工作，这样子啊。所以你可以用 one stage、two stage 后面这边 head 这样子啊，就是这边的一个很大的、很好的一个贡献。那 YOLO V4 more in detail is like this one， 这个 SPP。然后 this one is this contribution is not YOLO V4. This contribution is we call PANet, Test Aggregation Net. This is not YOLO V4 contribution. This is a paper called PANet contribution. This meaning you have a downsampling, you have upsampling, you do downsampling again. So this is a YOLO V4. I say again, RetinaNet here. RetinaNet is downsampling and then upsampling and then head. Based on the head, they can do classification, they do bounding box. Okay, based on the anchors. Okay. YOLO V4 actually based on we call PANet here. They have one more downsampling. Why? Why they want to have one more downsampling? Because see this one P5. You got the information from P5. You already have a C1 extraction. So from C1 to C5 and then to P5, you already extract 6 times. So it's the information here is far away from original raw data. 你如果用一般的像 Retina 那些，因为我们以这里来讲，它你的 P5， 你的 P5 基本上已经是这么多层。就我们以这里来看，你的 P5 已经是在这里了，就是你已经当 sample 5次以后再过来，这里又处理完，又过来这里，你这里的资料已经损失很多了。You lose a lot of original information here. Okay. So this is a weakness for the RetinaNet. Here, you lose a lot of information. Okay. So P5, you lose a lot of information. So how can we solve these problems? Remember, the original data is very important. Original data. So PANet, the paper PANet, they say, okay, we can do this one. We shortcut here and do downsampling. So you'll find this information N5 or we don't need N5, N4, based on N4. Okay, so you have C1 1, C2 2, N3 3, N4 4. So from here to the original raw data, you only extracted 4 times. 就你的 N 事实上距离你原来的 data 只有1、2、3、4个距离。你如果拿这里来做的话，这已经是第6个距离了。资讯已经可能很多资讯都不见了，很多资讯都不见了。那这有证明，这是对的哦。很多资讯因为萃取太出来之后，不要太复杂，你萃取太多，有时候资讯到这里是不见的哦。你这里再怎么分析都分析不出来，就消失掉了。所以 PANet 说不对，那我应当是从这里再进来，那至少这里我有 data 进来是最好，拍拍手。因为 this is more global information, this local information. So I have an information not only from here, but also I can have a global so this local information, the global information, I combine together. So the result will be, the information will be better. That's correct. But why not from C1? Why not we can connect to here? Why not? That's not their problem. That's a computer problems, GPU problems. Because if you extract the data from here, you have more parameters, more data, more parameters, and sometimes your GPU cannot run it. So if you have a powerful GPU, you can shortcut from here. You can keep more information. But because most of GPU are like only 3080, 2080, that's not powerful enough, so they do shortcut from here. 那是你 GPU 的问题这样子。So this one is better is because they have a local detailed information not only from here, they also have a global, that is global information from bottom, from top to bottom. 这样子. So they combine here, they combine local information, global information. So PNet will be better. And then here is head. Head is the other issue. Okay. But here still has problems. What's the problems? How can you improve this one? Because it's already complicated. So YOLO V4 is good, but it's not easy to modify. That's the problem because it's already complicated. Okay. 我一直强调说，不是不要用它，你是要用它，但是有些状况你用比较复杂的架构，你后面有问题的时候，你不知道哪边去改，因为它本身架构就复杂了，这样子。好 ，So YOLO V4 here they also include RPN here, so they have RPN here, and this part, this head. Because you have RPN, so you have an ROI alignment. RPN is meaning you detect any kind of bounding pass already have an initial result. And you normalize a line here. A line means you normalize to the same size and to do the more precise process. I said again, RPN is meaning you have an initial bounding box result. And then you do the normalize to be the same size and do the more further refinement process, and you got a better result. So this here, this is because of RPN. And after this one you can do bounding box refinement, do classification, and this one can do the mask segmentation. This one, 这是 bounding box， 这是 mask， 都可以做这样子。那这个跟这个没关哦。这是一个 module， 这是一个 module， 所以不管你前面用 Retina 用 VGG16 什么，到后面还是可以。那 VGG16 没有 upsampling， 就 upsampling 完以后，这边还是可以做一些处理这样子。就是每个都模组化的。OK， 那 mask here, mask is this original data to upsampling. This is mask. What do I mean mask? Mask is meaning foreground is 1, background is 0. So for each pixel, for the mask segmentation, is meaning for each pixel you classify to either foreground pixel or background pixel, so become segmentation. 你要做那个 segment， 把这区域把它萃取出来，那就是分前景跟背景是在这里。So this is the mask. This is the original information. 这是原来 upsampling 的原来的资讯在这里。那这里做 mask 的萃取，前景跟背景分萃取，对不起，分前景跟背景。那这两个 mask 套上去以后，你就把前景的资料抓出来就好了。所以 mask 事实上分2步哦。这一条路是做 mask， 这一条路是做 feature extraction， 然后2个再合在一起，那把前景资料再把它分离出来，这样子，这叫 mask。所以这里有2条路，这样子。好，那还有，我今天希望把这个讲完啊。So I try to explain this one in details. So hopefully you can understand. Based on this example, I hope you can understand what's the deep learning network. Okay. So assume we have an image 32 by 32. It's the image. It's the right hand. Okay. And either you write ABCD or 0 to 9, 0, 1, 2, 3 to 9. But this paper has some problems. Actually, this input here will be 0, 1, 2, 3 until 9, not ABCD, but you can apply to ABCD. 就说它这个 paper 有点讲错了，它这样是辨识0、1、2、3、4啊。好，那不管，我们就假设这是手写字哦。So input size is 32 by 32, and your graph value is between 0 and 255. That's the input. And you try to recognize the input digit is which one. So you try the ground truth here. You try to recognize. It's meaning, suppose for each digit 就是数字那个哈 ，suppose you collect 100 digits， 不同的手写 different kind of handwriting digits and 100 data. So this is 0. So when you input 0, your output 0 here will be right 1. Other class will be 0. That's labeling. So here we need to do the labeling. So if your input is 3, your output in the 3 here, you will become probability label to 1. All other digits will be 0. That's called labeling. So labeling is very important. 就是你输入是什么数字，你这里就要强制给它1，其他都是0。这是你的那个 label 的东西。所以 deep learning 就是要往你的 label 的，就 B and B plus B prime。B prime is the estimation result, extraction result. B is your labeling. That's mean ground truth. Okay, so this is the input. This is the output. So in this one, they separate to 2 parts. The first part we call feature extraction. This one is feature extraction. This part we call feature classification. So before there's a convolutional network, we talk about this one is 我们讲这个是要讲这个。I explain this one. Almost the first paper talk about deep learning. Okay, so I explain this one in details. So our purpose is try to do classification, because after you do extraction, what's the purpose? You do either our computer vision is a detection, tracking, recognition, 3D reconstruction, for purpose. For computer vision field, okay, we have 4 purpose: detection, tracking, recognition, 3D reconstruction. All can use deep learning. Okay, so in this case, we will do recognition. Recognition is 1 to many, 一对多的 classification. Detection is 1 to 2, 一对二 face or non-face. So this one, we also can apply to face detection. So if input face and you label it 2, one is either face or non-face. So one can do the detection. And we do classification here is because the input has a 0 to 10. So output will be 0 to 9. 0 to 9. So we have 10 classes. So for entire network, this part is extraction. After you extract the information, you do the classification. Before deep learning or convolution, people input is here. We don't have this one. This is a neural network. Before convolutional network, neural network, people do original data input here, directly input to here, and output. So people use neural network or use NLP, MLP neural network. Original, they input directly to the network. Why? So this they come. Why they think about I want to do extraction is because if I can extract important information for the input of a network, he think the result will be better. He's correct. He's correct. 就原始 data 基本上是原始的 network 值，就把原始 data 丢进去嘛，然后就辨识了。但是这会受光线影响，我们最怕影像受光线，会受杂讯、光线一大堆不好的因素影响，所以它的辨识率会很低，有时候还歪斜，也会影响。那怎么办？所以他们觉得说，哎，那既然我有 edge， 我会学过 edge detection。So what's the purpose for edge detection? You extract high frequency. You extract important features. So you think, okay, if I can input the edge detection result to this to here, probably the result will be better. He's correct because if you do edge detection, you don't affect it too much by the lighting. 边缘侦测不会受太多光线影响，因为边缘侦是对比啊，你的字跟背景、前景跟背景的误差对比，它可以把它萃取出来。那我如果把萃取的资料丢到里面去，不是我辨识率会更高，我更不会受这些杂讯影响，不会受这个光线影响吗？他这个 idea，这是我想的啦，我在想他的 idea 应当是这样子啊，我讲的啦。那我觉得他应该是这样在想，他这想法是对的，所以他就说，那但是问题是，好的 ，final problem is how can I use the convolutional process? Sorry, how can I use the network to represent the convolutional result? Right? 我要想，那我 network 怎么把整合到 network 里面去？我怎么把 extraction 整合到 network 里面去？他在想这个问题，所以他达到了，但没有人重视他，因为这时候他觉得说这好像没什么，但他把它做到了，所以我们来看他怎么做。Okay, so how can we embed the convolutional filter to the network? So what he did is this one. For each 5 by 5 window, 5 by 5, so he shift pixel by pixel shift. And based on 5 by 5 filters, he extract to be 1 pixel. 每5乘5的 filter 它就萃取成一个 pixel 嘛，跟 edge detection 一样啊 ，edge detection 用3乘3的 Sobol filter， 你是每个 pixel 都这样萃取嘛，那就用5乘5来萃取，那就一个 pixel。所以我们来看哦 ，the image size from 32 by 32 become 28 by 28. They lost 4 pixels. Left 2 pixel, right 2 pixel. 它左右各损失2个 pixel， 为什么？因为它是5乘5的 filter 嘛。Now 5 by 5, if I put on the corner here, the center will be, suppose the corner is 0, 0, right? So the center will be 2, 2, right? If I put a 5 by 5 filter to the corner here, the top left is 0, 0, pixel 0, 0. The center pixel will be 2, 2. So only 2, 2 have a value because of convolution. So he put this result to here. So he do scan line from top to bottom. So he will lose 2 pixels the left. The 2 pixels because 5 by 5. 5乘5是2个 pixel 不见了，右边2个 pixel 不见了，上面2个 pixel， 下面2个 pixel 都不见了，所以它的结果就变成 so result is 28 by 28. So later people say, oh, okay, I lose the information of boundary. So if I want to improve this one result, they will use a padding, right? The padding. So if I don't want to lose the information of boundary, I will do padding by 2 pixels. So the padding size will related to your filter size. Your padding size will be affected by your convolution window size. So if I do padding 2, and then the output size will be the same as the input size. Okay, back to here. So he used one filter to extract this original information to be one we call map, we call feature map. This image, this one, you can also call image, but no, people here call extracted feature map. So this one filter, 一个 filter 5层的 filter 的系数，它萃取1张。So total I have six filters， 我有6个 filter， 我就产生6张图，这样可不可以？它有6个 filter， 每个 filter 会产生1张新的萃取，就这个This original 3， 这是我们学长自己做的啦，我记得学长自己做的啊，学长把我教他分析。So I have 6 filters. I extract 6 feature map. Look like this one. 有人萃取上面边边，就是假设有人萃取3的上面下面，有人萃取这边，有人萃取 corner 的地方，有人萃取内部，他会自己去萃取，可以哦。这个每个萃取方向不一样了，可以摆这个方向不一样啊。所以 they design six filters and so for 6 feature maps. Okay, and then do downsampling. So how can they do downsampling? They do 2 by 2 and do I think it's average. I forget. Either maximum pooling. Maximum pooling is 2 by 2, 4 pixels. They pick up the maximum value. Or average is the mean. If sum together and divided by 4, 是平均值。这2个都可以，我忘记他这边用哪一个 field， 所以 the image size from 22 by 22 become 14 by 14. So this will become one we call block. So this one block, 2 layer, but actually we call one block. 这是一组啊 convolution downsampling, so become 6 images, feature and size 14 by 14. And they do again. So they do convolution again. Use 5 by 5 the same. Okay, but right now, from 6 features, they become 16. 它变成16个了。那这里要注意一下 ，this important is the filter is 3D filters. This filter is 2D. 5 by 5 is 2D. This one, they have a crossover. It's meaning, for example, my filter is 5 by 5 by crossover 6 maps. 就我的 filter 上不是只有5乘5，我还要跨过去这6个一起做。那它原始 paper 它有分为3个一起做，4个一起做，5个一起做这样子。那现在因为比较 powerful， 现在是6个全部一起做，就是每个 field 不是只有5乘5，还有这里我们写的，它是6个 channel 一起做。So this one will create one feature map. This is very important. Almost all the paper just write 5 by 5 or 3 by 3. They don't tell you the crossover process. Paper 都不讲 crossover 这个处理，他没有跟你讲。那记得这是3D 的，我一直跟你讲这是3D 的，所以是它这 field 是5乘5乘6，但是它 paper 不是6啊，它有分乘3、乘4、乘5的 crossover， 它有那个一个 table， 它有跟你讲。好，那我再回到这边，那所以每个 field 做完就1张图。So total they have 16 5 by 5 by some channel filters， 它总共有16个 filter， 每个 filter 是 3D 的，这样产生16张。目前没有问题，因为后面全部都是这样做的，后面的 network， 那就16个，就产生从6张变成16张。And then do downsampling again. So see here, the size is 10 by 10. Why? Because the filter size is 5 by 5, right? So 5 by 5 in the boundary, the border, they lose 2 pixels in the left, 2 pixels in the right. So 16, only a 14 by 14, because they lose 2 on left, 2 on right, so become 10 by 10. So here 10 by 10. They don't do padding, so it become 10 by 10. And then the result is 6 map, feature map. And this one we call local feature. 这些是我自己讲义，你们学长帮我把讲义加进去啊。因为你 extract more detailed information, we call local. We call local feature. And this one you still 5 by see. This one you still 5 by 5. This is 5 by 5. But this 5 by 5, because the image getting small, so your information become global. Global meaning in this one, probably you extract only the small corner. Global means you extract more large region because the image size is smaller, but your filter size is the same. So more downsampling, your feature extraction result will be more global. Okay, so this one called global information. And you do downsampling again. So finally, your size becomes 5 by 5. Original 32 by 32. You downsampling 1 time, downsample 2 times, so become 5 by 5. But you have a more base, more maps, or more channel. Original, you only have 1 image. Here, you have 16 images. So you have more information. And for this one, we input to the neural network 3 layers. Neural network. For why we 3 layers? See here. There was actually 3 layers because when we do like an NLP, what is it? NLP backpropagation. This one, most of NLP are 3 layers. 这是有2个了，这三个层，三个 layer。这 NLP 大部分这样子啊。Okay, so here they apply to the NLP for the classification. So for classification result, this regular network, 这是一般的 network. But because your output is 10 digits, so the output should be 10. 这样子。The other thing is that because this is 1D vector, so before you input to here, this we need to do, we call flatten, Flatten. Flatten is meaning you have 2D 5 by 5, you will become a vector 25, 5525. 你本来是 2D 的25的 image， 你要做输入，因为它是一个 network 只有 1D， 所以你要做个 flatten 的动作，把25的那个参数变成55，25变成25个 pixel。本来 2D 25变成 1D 的 pixel， 可是你总共有多少？你有总16张，所以你是25个 pixel 再乘上16个，变成一个很比较长的一个 flatten 的 1D vector， 然后输入到这边。变12、120再设计84，然后再慢慢变小。因为你这里 ，if here output is bigger, then this one should be longer. But this is small, so this output because this is small, so this will become smaller. So there's 3. So we call the count is a 5. What's 5? 1, 2 plus 3, 5. I say again. Not 1, 2, 3, 4, not 4 by 3. No. we use we for each down sampling we separate by based on down sampling， 记得是从 down sample 那边来分开，所以 down sample 之前我们就剩一个 block， 只是一个 block， 一次当一个 block， 这是第二个 block， 再加上后面3层的 network。So this one is a 2 plus 3 become 5， so they call the net 5， 是这个意思。所以当 sample 前面这样一组哦，这样一个 block， 不是独立一个 layer 这样子，这是2加3是5，人家称为 the net 5这样子。那这我大概讲完了。那之后所有的架构都是以这个架构为主在做的。好 ，OK， 那就今天就讲到这边。那我还会有问题再直接在那个线上可以问我这样子。那我们好像会开放一些名额进来做嘛，哈，40个，好，那我们开放40位学生进来我们这边做，就是在现场，在叫什么实体在这边做，要上网登记嘛，是不是？Google 表单在我们的 Moodle 上面，那你们就去填，有填到就可以来了。每天没有填到就柯达也差不多没有鼓励你们来了。那我们今天上到这边，谢谢。